The next question is 2328. 2328 is another synthesis problem where we start out with benzene and we react it a bunch of times and follow the products as they go through. So the first reaction is a Friedel-Crafts acylation. So we have the aluminum trichloride catalyst, which hopefully we're getting kind of used to seeing at this point, and we have an acyl group. So we're going to install that 4-carbon acyl group onto the aromatic. It doesn't matter which position, I just choose one that's convenient to draw. Once that's installed, we have 1, 2, 3, 4 carbons, the same as here. The chlorine is replaced by the aromatic. We can then react with Cl2 and FeCl3. This is a chlorination. But now because we actually have a group on here, it matters where the chlorine goes. This, because it has a carbonyl directly next to the ring, is a meta director, and so we should see the chlorine install only at the meta position. So now we still have the acyl group, but we also have a chlorine either down here or at the other meta position, which are identical. This is a Wittig reagent. We have a negatively charged carbon attached to a phosphorus. It's going to replace the oxygen and double bond to this carbon. So this carbon is going to be where that oxygen is, and we're going to have a double bond at that location as well. We'll have a mixture of cis and trans forms. We'd have to isolate the cis from the trans in the product. So our product will look something like this. This is the CH minus that gets joined on. Now it's the CH that's joined to this location. And this is the CH3 group over here. The next set of conditions is MCPBA, metachloroperoxybenzoic acid, which is a standard condition for making a peroxide. So we will have this aromatic. We'll have this as an epoxide, this is a peroxide that makes an epoxide. I think I misspoke earlier. And then we'd have the chlorine at this location. This epoxide can be opened up by a Grignard, which is what's happening here. So we have a C6H5MgBr, it's a phenyl Grignard, and so we'd end up having this phenyl go to the less sterically hindered side because it's in basic conditions and open up the epoxide. So we'll see the phenyl attach here, and we'll have the alcohol on this carbon, the more substituted of the carbons. It's going to be somewhat busy, so I'm going to abbreviate the phenyl as PH. So this is what our product looks like. Again, the phenyl is this group, the C6H5. And in case that light is getting you funny, that's what that product looks like. After we react this with phosphoric acid, we're going to dehydrate again. So we will end up forming an alkene between these two positions. Now it's possible to also get the alkene here, but because this is far more substituted, that's the more stable alkene that can form. So that's the Zaitsev product. That's what we will expect to see.